Hi everyone. So time for another homework video, and what we want to achieve is this. We have a ventilator with some, small pieces of cloth attached to it. You maybe know this from some old Hollywood movies. You might have seen this in some old Hollywood movies. It's basically just supposed to indicate if the ventilator is running or not. And the first idea is to do this with a static ventilator because it's easier. And once you achieve that, you can try it with a bit more complicated approach, the animated version of it. I'm providing the fan, of course, so you can download the file on the right side and then you can try it yourself. And as usual, the idea is that you try it yourself first. And if you succeed or fail, it makes then more sense to look at my solution. This is a better way of learning. So see you in a bit when we look at my solution. All right, let's start by analyzing how I created the fan. So here we have something that's mostly straightforward. So here the rotor, for example, is pretty clear. We can see I already created Tommy on the side. We will need this in a second. And what is maybe a bit more interesting is the cage. Since in Houdini, every edge is also basically a curve. And let's get rid of Tommy for a second. You can see here by just taking this geometry here, which is really just a subdivided tube, we can take those edges and then with a polywire, for example, turn them into a cage. Pretty handy. And then of course we put this into a group so that we can find it later and give it a color if you want. Then here we just adjust the whole thing a little bit, and then what we will find here for the second part is the actual animation of the head. So it's moving back and forth, but this is for later, so let's keep it turned off. And then we add the stand to it, and this whole thing, as we've seen, is actually way too big when we compare it to a Tommy. So what I do here is I just scale it down. I also use the Labs Quick material purely to give it a little bit of a shine, but this, completely unnecessary for this practice. But make sure you put the whole thing roughly at the right scale so that the simulation will feel correct. Okay, what we want to do with this is in the sim geometry node, I've already prepared a planar patch for our stripes and then the fan coming in with an object merge, of course. And you can see the scale is completely off. So let's first make sure that the whole thing makes sense. And I scale it down to something that is more or less reasonable. We can change it later, maybe 0.1. And then we want to attach it to the cage, of course. So first of all, let's make sure we separate the cage. I do this with a blast because thankfully I already prepared all the groups. So we take the cage and delete everything else. There we go. And of course, what we could do now, we don't want to manually position each stripe. We could scatter just on the surface of this cage. So let's try a scatter. The only problem with a scatter, besides having way too many points here, is of course that we would also get points at the top and at the back. So let's lower the number of points first of all. And what we could do now is somehow, and there are many ways of doing this, making sure that we only get points at the front. One thing you could play around with is a group node, maybe even based on the normals or something like that. But I'm a bit more lazy. I simply will take a clip node. Because in this case, why put too much effort into it? There we go. So we just clip this stuff away, something like this. And now I only have the front. And if I scatter on that, I will only get points at the front part. So let's take this and use a copy to points, of course, to copy our stripes onto the points. Here it is. And of course, the alignment is off. So we could, of course, assign normals to our cage here, which would be perfectly fine. But I'm a bit too lazy for that. I will simply rotate them around by 90 degrees around Y. There you go, something like this. And maybe scale them further down. Yeah, maybe something like that. And what you could at this point already be careful about, we will see that otherwise later anyway, is they are of course copied directly towards the points, so they might stuck into the cage. So at this point you could just move them away a little bit so that when we attach them, they're not actually stuck inside of the cage. So something like that maybe looks okay, I think. Okay, so let's make those stripes also reddish. Currently they take the color, by the way, from the scatter because our cage here is black. So the points will be black. So let's make sure we override that. We could do this afterwards, or we just colorize the points directly, something like that. There you go. And now, of course, let's use a Vellum cloth configure and a Vellum solver, of course, just to check if everything works all right. This is what I usually do before I start adding the constraints and all that. Let's press start and see what happens just to be safe. Okay, and they fall down like they should. Let's start to add the collision geometry to this. So maybe our cage here, we could use the whole cage if we want. Let's take this one for now. There you go. Now let's try this again if it's still stable. Yeah, that's good. Of course, it's not attached. And since we use this now as a static object, we need to attach those stripes to the static object, which of course we can do with the attach to geometry constraint. There you go. And when we run this now, at first, it looks actually pretty okay. But you might see there's some weird behavior on them. So some of them feel weirdly, rigid or something. This one, for example. And of course, you know why. You have to be really careful. You might have even noticed it. When you use the Vellum attach geometry, always be sure that you're only attaching what you need. By default, it will attach everything. So this is why it behaves so weirdly, and it's easy to forget that. Of course, the solution for this is the max distance. So let's find something that works. We're working at a pretty small scale, so we might have to put this in manually, but something like this looks fine, I think. And now let's run this again, and we should see that the whole thing falls much better. And we have no unexpected behavior, so that looks pretty good. Okay, brilliant. So we're almost there. So the rest is pretty straightforward. We can do some adjustments, of course, to the cloth constraint. One thing I usually always recommend is lowering the bend stiffness. It simply behaves better that way in my experience. And also what I would always check at this point is the thickness. So let's turn on the visualized thickness, and everything is fine. As you can see, they're not overlapping. But this is something you should always check. When your collision thickness is too big, so maybe something like this, then you will see that the objects basically collide with themselves already, and this will result in weird behavior. So always make sure, especially also in areas where you might not see it at first, that there are no collisions on the first frame with itself. Otherwise you can run into problems. This is a common problem I ran into. That's why I always make sure to check that. Okay, so now what we want to add is just a little bit of a force, because currently the ventilator is not on. The easiest way of doing this is just using the built-in force. So maybe 5 in Z, because that's here our Z direction. And this should work fine. Yeah, as you can see, not too bad. But personally, I prefer to not use that, but the internal pop wind, because then I have a bit more control over what it's doing. For example, I have the additional option of using the noise amplitude if I want it. So let's add here maybe 6 in Z, and let's run this again. And one thing you should see in the beginning is, I think this looks pretty good, but as you can see, it's very stretchy. So let's rewind and look at this again. So this is the normal neutral state of our stripes. And then they stretch like they're basically made of rubber, but maybe they should be made of cotton or maybe paper or something like that. So they definitely should not be that stretchy. Of course, the problem is that the stretch stiffness is already pretty high. So even if I would try to put this higher, it will not change the behavior. There are two options basically. We can lower the resolution. This is a nice little hack, but this time I want to have at least this kind of detail to get nice deformations. So I do the correct way of actually increasing the substeps. And what usually is a good starting point for me in production is 4. With 4 you can usually be pretty safe that the quality is high enough, but it's not too slow. Besides that, I also noticed that this works really well here. So you can see they don't stretch too much anymore. So brilliant. Basically what we have now is this whole solution. So let's maybe take the fan from the object merge it with the result, and then we look at the whole thing. And of course, if you're happy with this and you want to render it, just make sure that you cache it down here, of course, with a file cache. I keep it on the side because we don't need to do this right now, but always cache before you render, of course. So one small adjustment, maybe I don't like the one at the top. Easy to solve now that we have this set up. Maybe we just go a bit more aggressive with our clip node here. That would be the easiest way of solving this. There you go. And what we also can do is maybe in the scatter change the global seed a little bit. Depends a little bit on what you want. And maybe lower or increase the relax iterations, depending on what the result you like. And pretty much what we have now is the result we wanted. So this is our first part. Hopefully that shouldn't have been too challenging for you. There should be nothing new here. But let's now add a little bit more complexity to it by activating in the fan the animation node. Now with that come a couple of challenges with this setup that you have to be careful about. So when we look at the result, you can see something is weirdly off, and it's not at first obvious what happened. So let's have a look at what comes into our simulation, and then it should get clearer. So here, of course, with the stripes, they will be changing every frame. Why is that? Because all of a sudden the clipped version here that we use for our scatter will constantly get a different result with every frame, and therefore the position of our scatter points is changing, and therefore also our stripes. Now thankfully that is actually not a big problem, because everything that goes into the Vellum solver, as we know, only defines the starting point. So this is why the number of stripes or the position of the stripes is not changing actually, but the problem is actually the collision object. So here, this collision object is also changing because of our clip. The solution thankfully is pretty simple. We just have to make sure that our collision object is not changing over time. I mean, it can move, but it should not change its numbers. And thankfully, we actually have that version just before that. So a relatively straightforward solution, we just, as our collision object, or static object, we take the first geometry. And if you want to be super safe, you can also just put in here a time shift for your scattering version if you want, so that you always get the first frame, or 1001 in my case. So then, you know, if this bothers you that this is changing every frame, this is gone. But again, it doesn't actually matter because it will take the first frame as a starting state only anyway. Now, as soon as we now make sure that our static object is not changing its point count, even though it's moving, the whole thing is stable again, because our stripes here are now connected to the moving static object, which is not a problem as we've seen before. But there is one small thing you might want, and that is when you look at the whole thing, there is something not correct, and that is that the direction of our wind is always in Z, when it actually should come here from our ventilator itself. And this can be a little bit tricky if you want to do it in an elegant way, so I won't do that. You can use the pop wind direction that you already have here, the wind velocity. You could also, of course, use a pop fan cone if you want, even though I don't personally ever use it because it's pretty horrible the way it works with the cone angle, but you know, this could be a solution. But even that is not great because it has the same problem, it has a vector. Now what I would do here, there are ways of doing this procedurally, by the way, but I will simply use a line node that gives me an indicator of the direction. So I put this into the same vector as my pop wind, and I will use the same technique I used in the fan to move the fan back and forth, because we haven't talked about this, how I did this. This cage is moving back and forth by using this expression, using a sine wave. I did not animate this by hand, even though that's possible. But I made sure that I subtract the 1001 because I'm starting at 1001, and I want to make sure that on the very first frame the rotation is 0. That's why I did that. Then I multiplied the whole thing with 2 to speed it up, and when I put this into a sine wave, it basically just goes back and forth. But it would by itself go from plus 1 degree to minus 1 degree, because that's how sine waves work. So I multiply the whole thing with 30 so that the most extreme angle is 30 degrees, and then it goes back to another 30 degrees. Here you can see again how great sine waves are, because they feel very natural, because they slow down at the end and accelerate in the beginning, so to say. Now, how does it help us? We can just take the same expression, and even though we can't use it directly on our line here, we can at least use the same logic. So if we want to rotate this around y, we can do this, and then you can see that, of course, the x direction, which is this axis here, will increase. So let's put our expression here. And of course, this is way too much, because we want to have it relative to our z direction, which actually it was supposed to be 6. And now what worked for me was simply looking for a number at the extreme. Let's find the extreme. That should be there. That works with my 6. And something that I think that worked was 4. Yeah, and here you can see. Just find the extreme point and put in what works for this. And now it will basically move in the same direction because it's using the same expression, even though the number is different. So this is a good way of testing if your vector is correct. And now that we have something that works, we can just copy that whole thing and then just go inside to our pop wind, or maybe the pop cone fan if you want, and then just paste this here as a relative reference. And then you can see that our direction of the wind should rotate with our cage. Now there are other ways of doing this, more complicated ways. For example, you could add a line to your cage that rotates with a transform and then read out the beginning and the end point of that vector, subtract the ones from each other, and then you actually have the vector that it points towards. That is an option, but I think it's unnecessarily complicated. Doing it manually is perfectly fine as well. All right, and what we get out of it is now a rotating version of our fan or ventilator, even with the force moving in the right direction with it. So I hope this is helpful. Thanks very much and see you later. Cheers.